Hello there and welcome. Before you get too comfortable, do take a moment to like the video and subscribe if you'd be so kind. And while you're settling in, let me know in the comments where you're tuning in from and what time it is for you just now. Now dim the lights and let's ease into tonight's journey together. This evening, we'll be drifting gently through the quiet corridors of human thought and ingenuity, tracing the long, slow arc of something so deeply woven into the fabric of our lives that we rarely pause to consider it. The invention of time, not time itself as an abstract backdrop to existence, but the ways in which we, as fallible and curious beings, have measured it, shaped it, and sometimes even wrestled with it. From the flicker of shadows on ancient walls to the humming pulse of atomic clocks, the notion of time has passed through countless hands, cultures, and curiosities. It began not with grand revelations, but with quiet observations of the sun's rise and fall, of the moon's patient turning, of seasons sliding by with a rhythm as slow as breath. The earliest understandings were not captured in words or instruments, but in the repeated habits of daily life, when to sow, when to reap, when to pray, and when to rest. In this story, there are no battles, no kings, no moments of thunderous discovery, only the slow, soft layering of ideas and objects, sunsticks, clepsydras, candles, gears, each contributing a tiny fragment to the great mosaic of human timekeeping. It is a story of monks and merchants, scholars and seafarers, craftsmen and contemplatives, and through it all the quiet ticking of progress, not loud or urgent, but steady, always steady. So let us begin at the beginning, where the line between night and day first invited our ancestors to wonder. How long is a moment, and when will the next one come? Let us now slip quietly into a world untouched by clocks, where time was not something spoken of with precision, but rather felt, like warmth on the skin or hunger in the belly. Long before sundials carved their figures across stone, before even the concept of hours found a name, there were shadows. Moving gently across cave walls, the shifting of light became, for early people, the first silent language of time. Picture, if you will, a small settlement, not grand, not permanent, but tucked against the edge of a wooded slope, perhaps somewhere near what we now call Anatolia, or the grassy uplands of early Mesopotamia. The people here did not mark birthdays or observe anniversaries. Their sense of past and future was woven into the cycle of seasons, the blossoming of certain trees, or the disappearance of particular birds from the skies. The sun was, quite naturally, the earliest and most obvious teacher. It rose without fail, climbed to its peak, and dipped again behind hills or canopy. Those who paid attention, hunters, foragers, and those tasked with tending the fires, would have noticed how their shadows lengthened and shrank, depending on the time of day. It is not difficult to imagine a quiet understanding emerging, passed through gestures and repetition. The long shadows mean morning, the short shadows mean noon, and the growing ones tell of evening's approach. Time, then, was circular and not yet counted. Days returned, like footsteps retraced. The moon's waxing and waning gave a gentle rhythm to months, though the term itself had no meaning yet. It might be noted that the river would swell after the full moon, or that certain fruits ripened in the moonlight of the fifth cycle since snow. These were the earliest calendars, made not with ink and parchment, but in memory and motion. As communities grew and remained in place for longer spans, more deliberate observations began to emerge. Stones placed upright might cast telling shadows. A notch cut into the bark of a tree or a line traced in soil could serve as a marker. simple, almost childlike in its innocence, yet quietly profound. A person might return to the same spot each morning to see where the shadow fell, using its position to know when it was time to begin a certain task, when to set out for water, or when to begin preparing the meal. These methods were not precise, and they were not meant to be. Time was never something to be dissected, only noticed. The moments were not called hours, but they passed just the same. A long walk took one kind of time, a short story shared beside the fire, another, the ticking of the heart, the beating of wings, the fall of a leaf, all served as cues, small and unnoticed, yet always guiding. There is something quietly lovely in imagining these early humans not rushing but attuning, their lives moving not against time but with it. The absence of clocks did not mean chaos, rather it allowed for a gentler rhythm, one in which light and shadow, hunger and rest dictated the shape of a day. Children would grow into this understanding without ever being taught it formally, much as we today learn to breathe without instruction. In some regions, especially those closer to the equator where day and night divide more evenly, this early sense of balance was particularly strong. But in others, where seasons brought longer nights or seemingly endless days, different markers were required. The stars became companions in the darker months. One might watch for the rising of a particular constellation to know when to begin planting, or when the rains might return. Even dreams, perhaps, were touched by time. The length of sleep, the moments before waking, before mechanical alarm bells or flashing screens, a rooster's crow, or the changing of the wind would serve to stir one from slumber. It is worth noting how in tune such lives must have been not only to the external world, but to the inner body, the rhythm of breath, the pulse of need. This early period of human experience, stretching back tens of thousands of years, remains largely silent in our records. No written notes, no surviving instruments. And yet, the understanding of time was there, not in terms we might recognize today, but in ways that shaped every aspect of living. To rise with the sun, to eat when the body asks, to gather when the fruit is ripe, to sleep when darkness falls. These are, at their core, the first clocks. They were clocks made not of metal, but of memory, of repeated patterns, watched and remembered. There would have been elders, no doubt, who were more attuned than others, the ones who could sense the shift of season a little sooner or judge the lateness of the day from the warmth of the earth. In some communities, such skills may have been held in reverence, quietly admired, not as magic, but as wisdom, the wisdom of paying attention. And so, before there were dials or digits or deadlines, there were shadows. Quietly stretching across the earth, they marked the passing of time not in urgency, but in presence. To live by them was to live slowly, in accordance with things beyond one's control, but not beyond one's understanding. The invention of time did not come in a single moment. It was not the product of one mind, but of many, across centuries. And in this early stage, it was less about inventing time than it was about recognizing its gentle presence all around. As human settlement deepened and societies grew more intricate, the need for more dependable ways to mark time began to emerge. The gentle observation of shadows and the turning of the stars, though sufficient for daily rhythms and seasonal transitions, did not always offer the granularity required by developing customs, rituals, and civil arrangements. And so, quietly, humbly, the first instruments of time came into being, not yet mechanical, but flowing and granular, echoing the slow and steady movement of life itself. Water was among the earliest companions in this endeavor. in the cool, shaded interiors of ancient temples and scholarly halls, the water clock, or clepsydra as the Greeks would later call it, began to find its form. It did not tick or strike, nor did it count with numbers at first. Instead, it dripped. A vessel filled with water, carefully perforated at the base, would release a slow and steady stream into another container below. As the upper jar emptied, the passage of time could be inferred by the level rising in the lower. It was a soft, almost meditative method. No rush, no clangor, only the hushed murmur of droplets falling one after another. The earliest known examples of such devices have been found in Mesopotamia and ancient Egypt, dating back over 3.5 millennia. In Egypt especially, water clocks were used in the temples, where religious observances required an accurate measure of the night. As the sun disappeared and shadows no longer served, the movement of water took over, offering a way to divide the long hours of darkness into ordered segments. Priests relied upon these clocks not only to determine the timing of rituals, but to know when to speak certain prayers, when to light lamps, when to tend the sacred flame. To the modern ear, the term clock may conjure images of ticking hands and ringing bells, but the clepsydra was more intimate, more elemental. One might imagine a quiet stone chamber, the air cool and faintly perfumed with oils, a single flame flickering beside the water vessel. Each drop, falling into its bowl, carried a weight of meaning, not in seconds, but in presence. The stillness was the measurement. Elsewhere, particularly in arid regions where water was precious or scarce, sand became the medium of choice. The hourglass, that familiar twin-globed instrument, had not yet assumed its iconic form, but the principle was already in quiet development. Sand, like water, moved with gravity's patient pull. When carefully dried and finely sifted, it could pour with remarkable consistency. The Greeks and Romans would later refine these methods, creating devices to measure speeches in courtrooms or periods of study and exercise. Though less accurate by modern standards, these early devices were deeply valued for their reliability. They did not depend on the sun's presence or the clarity of stars. Instead, they operated within enclosed spaces, quietly serving in places where knowledge, discipline, or devotion required a subtle awareness of passing time. It is worth pausing to consider how such tools may have been perceived. To us, they are relics, curiosities behind glass, but for those who used them, they were something more, perhaps even magical in their precision, or sacred in their silence. The slow, visible passage of sand through a narrow neck, the sound of water slipping steadily from one chamber to another. These were not simply mechanisms, they were representations of time itself, made observable and to a degree manageable. In places like Babylon, and later in the great centres of learning, such as Alexandria, these instruments would have stood alongside scrolls, instruments of astronomy, and early maps of the stars. Scholars would consult them as they pondered the movements of the heavens or calculated the angles of the sun's ascent. In such contexts, timekeeping was not about strict schedules or prompt arrivals. Rather, it was part of the broader philosophical inquiry: how the world turned, how the seasons unfolded, how change occurred in regular, comprehensible patterns. The designs became increasingly elaborate. Some clepsydras incorporated floats that would rise as water collected, triggering small figures to move or gongs to sound. Others included inscriptions along the sides to show the hour, with adjustments made for the shifting lengths of days across the year. In China, where the art of timekeeping developed along its own elegant path, Water clocks evolved into towering contraptions with intricate gears and escapements, anticipating mechanical clocks by many centuries. Still, at their heart, these early instruments retained a kind of softness, a humility that reflected the culture and values of their time. They were not instruments of control or industrial discipline. They were tools of alignment, helping humans live more closely with the rhythms of their world, their gods, and their communities. One might imagine a scholar in Han Dynasty China rising before dawn, lighting a lamp and consulting a water clock before beginning his readings. Or a temple acolyte in Thebes, crouched beside a slowly dripping clepsydra, watching the level rise until it reached the notch that signified a new portion of the night's vigil. These were quiet, reflective moments, not tasks imposed by urgency, but gestures of devotion, both spiritual and intellectual. As with all things, time instruments began to spread, to trade, to adapt. The ideas passed from one culture to another, refined and reimagined, but the essential principle endured. To measure time was to pay attention, to see the unnoticed, to listen to what moved slowly. There was, in these early attempts, no race against the clock, only a reverence for the steady and an appreciation for the ephemeral. And so we find, in the movement of water and the flow of sand, a first great turning point. No longer content with natural signs alone, humanity began to create time, not in the sense of inventing it from nothing, but by giving it visible, tangible form. A bowl, a hole, a trickle, a grain, simple things. Yet with them, time became something we could watch, something we could measure, if gently, something we could begin, in a quiet way, to understand. As the sun traced its silent arc across the heavens, casting its warmth and shadow upon all below, ancient peoples found in its steady rhythm a means of shaping their days with greater definition. From the open courtyards of Babylon to the stone terraces of ancient Greece, the sundial emerged, not as a sudden invention, but as a quiet refinement of older observations, made more deliberate, more enduring. The sundial, at its heart, is a simple instrument, a stick in the ground, the gnomon, casting a shadow upon a marked surface. But simplicity, as is often the case, can be deceiving. To build a true sundial is to possess a subtle understanding of the sun's journey, the earth's tilt, the turning of the seasons, and the latitude of one's place upon the globe. These were not instruments to be taken lightly, but the result of careful observation and thoughtful design. Early sundials appear in many corners of the ancient world, but some of the most refined came from Egypt. There, in the land of enduring stone and long horizons, the sun was both deity and guide. Obelisks, tall, slender monuments, may have served not only as spiritual symbols, but as early solar timekeepers. As the shadow of an obelisk moved across the ground, its position at different hours would be known to those who watched, not just as a curiosity, but as a marker of sacred rhythms. By around the 8th century BCE, the Babylonians had begun dividing the day into 12 hours of daylight and 12 of night, a division that would echo down through the centuries, even though daylight varies with the seasons. This meant that their hours were not of fixed length, but changed gently from summer to winter. Sundials, then, had to reflect this softness, curving their hour lines to account for the shifting path of the sun. It is in such delicate adjustments that we glimpse the quiet brilliance of these early thinkers. The Greeks, ever drawn to precision and philosophical elegance, expanded upon these ideas with both rigor and artistry. The gnomon became more than a stick. It was shaped, angled, and aligned to true north. The surfaces upon which shadows fell were carefully carved, sometimes as flat discs, sometimes as concave hemispheres. Inscriptions marked the hours, and in more advanced designs, even the seasons. These sundials were not merely practical tools, they were expressions of learning, set into public squares, temple grounds, and the gardens of private homes. It is worth imagining the experience of reading such a dial. There is no ticking, no flashing, only the quiet sun, moving as it always has, and the shadow inching forward upon stone. To consult the sundial is to pause, to look skyward, and to remember one's place in the greater turning of the world. It is not the time that rushes by, but the observer who chooses to stop. Among the Romans, sundials became increasingly common, though not always beloved. The playwright Plautus, writing in the 2nd century BCE, complained that sundials had ruined the day, forcing men to mark their lives by hours rather than need or desire. "The gods damn the man who first discovered the hours," he wrote, "and who first set up a sundial here to cut and hack my days so wretchedly into small pieces." Even then, it seems, there was a tension between the freedom of natural time and the order imposed by instruments. Still, the Romans embraced the sundial, erecting grand versions in cities and smaller, portable models for travel. One particularly striking example was the Solarium Augusti, built by the Emperor Augustus in the Campus Martius. Its gnomon was an Egyptian obelisk brought from Heliopolis, and its dials spanned a wide marble plaza, the shadow of empire cast upon the stones of time. Sundials also had a place in domestic life. Wealthy households might possess their own instruments, sometimes ornately decorated, their surfaces etched with Latin phrases or poetic observations. "I count only the sunny hours," one common motto read, a quiet reminder of time's fleeting pleasures and the value of light over shadow. But sundials were not only for the learned or the powerful. In marketplaces, in courtyards, beside wells, simple versions offered guidance to passers-by. They required no winding, no flame, no upkeep, only the sky above. And in this way, they connected daily routines to something far older and vaster, the solar passage itself. In India, too, sundials found a sophisticated expression. The great observatory at Jaipur, built in the 18th century by Maharaja Jai Singh II, contains the world's largest sundial, a vast triangle of masonry nearly 30 meters high. Its shadow, cast upon an elegantly curved scale, can tell the time to within a few seconds. But its grandeur belies the same principle as the simplest stone gnomon, to track the light, and thus the hours. Perhaps there is something poetic in the way sundials ask us to look not at the device, but at its absence, at the shadow it casts. Time, after all, is not a substance we can hold, but a pattern we can trace. A sundial, then, is a kind of invitation to slow down, to notice, to engage with the sun not just as warmth or brightness, but as measure. It reminds us that time is always passing, but not always rushing. In monasteries, sundials often marked the canonical hours, guiding monks in their cycles of prayer and labour. The bell might ring when the shadow struck a certain line, summoning the brethren not to urgency, but to devotion. And so the sundial became not only a civil tool, but a spiritual one, a bridge between heaven and earth, sky and stone, light and life. Today, sundials are often decorative, their hour lines weathered, their gnomons slightly askew. Few consult them in earnest, but they remain in gardens and courtyards as quiet witnesses to an older way of knowing time, one that did not blink or buzz, but asked us simply to wait and to watch. Long before the sweep of mechanical hands across a clock face, time was charted not by seconds and minutes, but by observation, by ritual, and by an ever-deepening relationship with the natural world. In ancient Babylon and Egypt, two of the earliest and most influential cradles of civilization, time was not merely tracked, it was honored, studied and woven into the rhythms of civic, religious, and agricultural life. In Mesopotamia, the land between the Tigris and Euphrates rivers, the Babylonians developed a timekeeping tradition that continues to shape our modern notions of hours, minutes, and degrees. Their system, grounded in a sexagesimal, or base 60, number structure, seems to have arisen from a blend of practicality and celestial observation. 60 is a number divisible by many others, 2, 3, 4, 5, 6, and this made it well suited to dividing the sky, the circle, and eventually the day. To the Babylonians, the heavens were a vast and ordered clock. They observed the stars, planets, and particularly the movements of the moon, whose phases gave form to their months. Lunar eclipses, solstices, and equinoxes were recorded with astonishing precision, inscribed onto clay tablets that have endured for thousands of years. Time, for them, was deeply connected to divine will. The gods moved in the heavens, and their patterns told of things to come. But in the practical rhythms of daily life, the Babylonians gave us something quite enduring: the division of day and night into 12 equal parts each, resulting in a 24-hour cycle. These were not hours as we know them now, fixed and identical regardless of the season, but rather seasonal or temporal hours, which changed in length depending on the time of year. In summer, a daylight hour was longer, in winter, shorter. Night hours followed the same rule, stretching or shrinking with the darkness. This approach, later inherited and refined by the Greeks and Romans, recognized time as a living rhythm rather than a rigid structure. One can imagine a Babylonian priest or scholar marking the passage of these hours not with a dial, but with the movement of light, the ringing of a bell, or the reading of a tablet. Time was read in the sky, felt in the length of shadow, heard in the hush or bustle of the city. Meanwhile, along the banks of the Nile, the ancient Egyptians developed their own profound relationship with time, grounded in cycles of flooding, planting, and harvesting. The annual inundation of the Nile was not merely an agricultural event. It was the very heartbeat of Egyptian civilization. Its timing was so vital that it shaped the structure of the Egyptian calendar, which in turn shaped nearly every aspect of life. The Egyptians devised a solar calendar, consisting of 12 months of 30 days each, with 5 additional epagomenal days added at the end of the year to complete the solar cycle. These extra days, considered outside the normal order of time, were often reserved for religious observance and mythic commemoration. This 365-day calendar was astonishingly close to the actual solar year, and it would eventually influence the Julian and Gregorian calendars we use today. Yet, alongside their solar reckoning, the Egyptians also observed the stars, and in particular the heliacal rising of Sirius, the star they called Sopdet. This bright star's annual reappearance in the dawn sky heralded the approach of the Nile flood and marked the beginning of the new year. It was a celestial signal of renewal and an enduring symbol of the connection between heaven and earth. In temples and palaces, time was also measured more intimately. The Egyptians, as we've seen before, used water clocks, often in the form of small stone vessels with a hole near the base. These clepsydras were sometimes inscribed with hour lines that varied according to season, reflecting their awareness of temporal fluctuation. Such devices were essential in temple rituals, ensuring that prayers, offerings, and ceremonies occurred at their appointed hours. The Egyptian concept of time, known as nehe and jet, reflected a duality. Nehe represented cyclical time, the endless, recurring nature of days, years, and cosmic order. Jet, on the other hand, referred to linear, unchanging eternity, the timeless state of the gods and the afterlife. These were not scientific distinctions, but deeply philosophical ones, shaping how Egyptians understood existence itself. Imagine, then, a morning in Thebes. The sun rises behind the pylons of a great temple, casting its first golden rays upon columns carved with hieroglyphs. A priest stands silently beside a clepsydra, watching the water rise, waiting for the moment when the shadow tells him it is time to chant the morning litany. Outside the temple, farmers look to the sky, scanning for the position of Sirius, gauging the readiness of the fields for the next season's sowing. Children learn the months, not from calendars on walls, but from the rituals of their households. The feast of Opet, the coming of the flood, the time when certain flowers bloom, or the days when boats are blessed. Time in such a world is not abstract, but embodied. It smells of incense and river silt, tastes of barley bread and sweet beer, sounds like flutes at midday and hymns at dusk. Both Babylonian and Egyptian timekeeping traditions remind us of a world where to measure time was not simply to organize life, but to participate in a greater harmony. These ancient cultures understood time not as a commodity, but as a current, something to be aligned with, respected, and followed. Their instruments were made not to control time, but to witness it. And so we see, in the hours of Babylon and the calendars of Egypt, a deep, patient unfolding of human thought. Not dramatic, not rushed, but gently observant. Time became something that could be shaped, marked, and shared. Something that moved through the heavens, through rivers, through rituals, and quietly, enduringly through us. As the golden light of understanding continued to dawn upon the ancient world, it was the Greeks who turned their minds most deeply to the nature of time itself, not merely its measurement, but its meaning. Where the Babylonians and Egyptians had focused on the practical and celestial rhythms of time, the philosophers of Greece sought to understand time in more abstract, conceptual terms. They wondered not only how to divide a day, but what time was, and whether it had a beginning or an end. To begin, we might linger a while in the city of Athens, sometime in the 5th century BCE. The sun, as always, arcs gently over whitewashed walls and dusty olive groves, amidst the hum of the agora and the rustling of scrolls in shaded colonnades. A group of men gather in quiet discourse. They are not scientists in our modern sense, but thinkers, philosophers, seekers of wisdom. And among their questions, one stands silently at the heart. What, after all, is time? Heraclitus of Ephesus, sometimes called the weeping philosopher for his sombre reflections, was among the first to suggest that time and change were inseparable. Everything flows, he said, or as the phrase is often translated, you cannot step into the same river twice. In this view, time is not a series of fixed points, but a constant state of becoming, always moving, always in flux. It is a concept that gently unsettles, even now, with its insistence that all things are in motion and that permanence is an illusion. Parmenides, in contrast, offered a more austere vision. He claimed that change itself was illusory and that all being was one, unchanging, and eternal. Time, in this sense, was a kind of trick, a veil drawn over the truth of existence. This was a difficult position to maintain, and one that left many of his successors puzzled or quietly unconvinced. But it raised a question that would echo through centuries. If time seems real, but cannot be grasped or held, what is its true nature? Then came Plato, whose writings in dialogues such as the Timaeus touched delicately on the structure of the cosmos and the role of time within it. For Plato, time was created by the demiurge, a divine craftsman, as a moving image of eternity. He envisioned the heavens as a great rotating mechanism whose circular motion gave birth to the measurable patterns we call days, months, and years. Time, then, was not eternal, but had been created, a copy of something more perfect, more still. This idea that time was a kind of echo or reflection of higher realities was deeply influential. It allowed for a universe that could be both ordered and divine, where the regularity of celestial movements was not just useful for calendars, but meaningful in a metaphysical sense. One can picture a student of Plato gazing up at the stars, not merely to measure their rise and fall, but to contemplate the eternal truths they might reflect. Aristotle, Plato's most famous pupil, offered a more grounded and systematic account. In his treatise Physics, he described time as the number of motion in respect of before and after. For Aristotle, time did not exist independently as a kind of container or river, but was a measure, something we perceive through change. If nothing moved, there would be no time, a tree that does not grow, a day that does not turn to night. In such a world, time would have no presence. This definition, though quietly stated, carried great weight. It positioned time as something relational, not a substance, but a kind of counting, an awareness of succession. It allowed for both the regularity of sundials and the experience of waiting, of remembering, of anticipating. Time was not a thing in itself, but a way of noticing what changed. Beyond philosophy, the Greeks also contributed to time's practical organization. The city of Athens, for instance, operated on a system of 10 civic hours in both day and night, adjusted throughout the year. Public events, court proceedings, and festivals were governed by these divisions, often announced by the sounding of a bell or the movement of a water clock. In some temples and observatories, sundials and clepsydras stood as gentle companions to philosophical speculation, one measuring, the other reflecting. The Stoics, too, held time in contemplative regard. For them, the universe was a living organism, governed by logos, a rational principle that pervaded all things, including time. They taught that each moment was part of a larger, coherent whole, and that to live well was to live in harmony with the unfolding of time. Marcus Aurelius, emperor and Stoic philosopher, wrote in his Meditations, "Time is a river, a violent current of events, glimpsed only briefly and gone." And yet, he counselled acceptance, patience, and presence within it. Even the Epicureans, who rejected divine intervention and emphasized the pursuit of tranquility, viewed time as a source of reflection rather than anxiety. Their advice was simple: live modestly, avoid unnecessary desires, and make peace with the passage of time, for it is indifferent to all things, yet shapes them all the same. Across these varying schools, Heraclitean, Platonic, Aristotelian, Stoic, we see not a single definition of time, but a chorus of quiet meditations. Time is change. Time is illusion. Time is number. Time is divine image. Each view, though different, shares a certain softness, a recognition that time is not something to be conquered, but something to be understood, or at the very least, lived with thoughtfully. There is something quite gentle in this approach. Unlike later periods that would seek to master time, to pin it down and parcel it out, the Greek tradition often treated time with reverence, even a touch of melancholy. It was seen not as a resource, but as a presence. Part of nature, part of mind, part of the soul's quiet inquiry. And so, in the shaded courtyards of Athens, in the lecture halls of Alexandria, in the scroll-lined rooms of the Lyceum, The Greeks laid the foundations not only for our measurements of time, but for our contemplation of it. They offered us not rules, but questions, and in those questions a kind of peace, the kind that invites us not to hurry, but to think slowly, and to listen to the quiet passage of time as it moves gently through us all. As the Greek world passed its intellectual torch to Rome, time began to take on a more structured, more civic quality. Where the Greeks had speculated, the Romans administered. Where the philosophers mused over the essence of time, Roman officials looked to its function. In the hands of the Roman state, time became a tool of order, a way to govern, to legislate, and to unify a sprawling empire under a common rhythm. The Roman calendar, with all its twists and reforms, is perhaps the most enduring symbol of this transformation. It began, as so many ancient calendars did, with lunar observations and local traditions. The early Roman calendar, attributed in legend to Romulus himself, consisted of 10 months, beginning in March and ending in December. It left a puzzling gap during the winter months, a period essentially outside of formal time. In this original scheme, March, Martius, was named for Mars, the god of war, and marked the beginning of the campaign season. It was a calendar tied to action, to agricultural cycles, and to military expeditions. The months that followed, April, Aprilis, May, Maius, and so on, bore names reflecting deities, festivals, or simple numeric order: September, October, November, and December, meaning 7th, 8th, 9th, and 10th, even though they now fall 2 places later in the year. Eventually, a reform under Numa Pompilius, the legendary second king of Rome, added January and February, giving the year its full 12 months. But even so, the calendar remained tied to the moon, and was frequently misaligned with the seasons. To correct this, an extra month, Mercedonius, was occasionally inserted, but its use was inconsistent and often subject to political manipulation. Priests known as pontifices were charged with managing the calendar, and their decisions held significant civic weight. By delaying or hastening the insertion of leap periods, they could extend or curtail the terms of magistrates, influencing elections, taxes, and legal processes. Time, quite literally, became a matter of politics. This growing disorder culminated in the late Republic, when the calendar had drifted so far from the solar year that it no longer aligned with the seasons. It was Julius Caesar, in 46 BCE, who undertook the most significant reform. With the help of Greek astronomers, particularly Sosigenes of Alexandria, he introduced a new solar-based system, the Julian calendar. The Julian calendar abandoned lunar reckoning and adopted a year of 365 days, with a leap day added every 4 years. Months were standardized in length, and the new year was moved to begin in January. In that first year of reform, the calendar was adjusted by adding an extraordinary 90 days, creating what came to be known as the last year of confusion. But from this confusion emerged clarity. The Julian calendar, with minor revisions, would remain in use across Europe for over 1,600 years, and in some places even longer. It was a marvel of simplicity and durability, a calendar designed not for temples, but for empire. The calendar, however, was only one part of Rome's growing relationship with time. As the state expanded, so too did the need for coordination, of armies, of harvests, of taxes, and treaties. Timekeeping began to assume a more practical and public form. In cities and camps, instruments were built not only for study, but for service. The sundial, introduced to Rome from Greece, became a common feature of public life. The first known sundial was erected in Rome in 263 BCE, captured during a campaign in Sicily. It was set up in the Forum, where it caused both curiosity and confusion, as it did not account for the differing latitude of the two regions. Eventually, more accurate dials were constructed, including the massive solarium of Augustus, whose shadow fell upon an engraved calendar of the year. These dials served not only to tell time, but to symbolize order, the emperor's authority reaching even into the hours of the day. It is in such gestures that we see Rome's vision of time, not fluid, not speculative, but structured, civic, and centralized. The daily schedule of Roman life was increasingly bound to the hour, marked by the ringing of bells, the lighting of lamps, the opening and closing of markets, the marching of legions. The hours of the Roman day were, like those of Babylon, temporal. 12 divisions from sunrise to sunset, adjusted with the seasons. But within this flexible frame, a routine emerged. The hora prima marked early morning, hora tertia, mid-morning, often the time for business and legal affairs. Hora sexta, midday, the origin of our word siesta, was a time of rest. Hora nona, late afternoon, might see the reopening of courts or shops. By evening, the day's labours came to a close, and the city settled into its quieter rhythms. Though mechanical clocks as we know them did not yet exist, the Romans began to experiment with more elaborate water clocks. These were used in temples, courts, and even theatres to measure speeches, ceremonies, and intervals. Vitruvius, the Roman architect and engineer, described a number of such devices, some of which used weights, pulleys, and floats to mark the passage of hours more precisely. These clocks, while still limited in accuracy, reflect a growing desire not just to observe time, but to manage it, to bring it indoors, to align it with the needs of law and commerce, to make it visible and dependable, even when the sun was hidden or the stars obscured. It is also in Rome that we find the roots of many temporal customs still with us today. The division of the day into 24 hours, the names of the months, the use of calendars to coordinate public life, even the idea of a workday followed by a period of leisure or rest finds echoes in Roman scheduling. But beyond all this structure, there remained a quiet awareness of time's deeper qualities. Roman poets and philosophers often returned to the theme of tempus fugit, time flies. Horace wrote of the fleeting hour, urging readers to seize the day. Seneca, in his letters, reminded his readers that while people guarded their wealth, they often squandered their time, the one thing they could never regain. And so, amidst all the administration and reform, the Roman view of time retained a certain duality. It was both a civic necessity and a philosophical meditation. It was carved into stone, yet slipped through one's fingers. It governed the hours, yet humbled the mighty. From the orderly streets of Rome to the farthest provinces of the empire, time became a framework, not just for the functioning of daily life, but for the unfolding of a vast, interconnected world. The legacy of Roman timekeeping is not only in the names we still use or the calendars we still follow, but in the very idea that time can be shared, that millions of lives across distances and cultures might move to a common rhythm. As the Roman Empire gradually gave way to the shifting mosaic of medieval Europe, the sense of time, once governed by civic calendars and imperial routines, began to take on a new, more contemplative shape. In the quiet seclusion of monasteries, time was not measured by trade or treaties, but by devotion. The passing of the hours became not an administrative matter, but a spiritual one, gently punctuated by prayer, song, and silence. Within the walls of these monastic communities, scattered across the hills and forests of early medieval Christendom, the day unfolded according to a pattern known as the Divine Office, a sequence of 8 periods of prayer, known as the Liturgy of the Hours. This structure, drawn from Jewish traditions and refined by Christian monastic orders, offered a way to sanctify time, turning each day into a quiet liturgical journey from darkness to light and back again. The origin of this structure can be traced in part to St. Benedict of Nursia, whose Rule of St. Benedict, written in the 6th century, provided a template for monastic life that would echo across Europe for centuries. In his rule, Benedict outlined a life of stability, obedience, and prayer, centered around regular intervals of communal worship. Time, in the Benedictine vision, was not to be filled with busyness or idle speculation, but ordered toward the contemplation of the divine. The hours themselves had names, each with its own place in the day's unfolding. The first was matins, or in earlier usage, the night office, held in the deep hours before dawn. It was a time of darkness and stillness, a vigil kept while the world slept. Next came lauds, as the light began to grow, a service of praise welcoming the new day. Prime, the first hour, followed with the rising sun. Then terce, sext, and none. The 3rd, 6th, and 9th hours of daylight marked the mid-morning, noon, and mid-afternoon, respectively. These were simple services, short and steady, calling the brothers back from their tasks to refocus their minds. Vespers arrived with the evening, as lamps were lit and the day began to close. And finally, Compline, the night prayer, marked the end of waking life, a quiet bidding of farewell to the day before rest. This cycle, repeated day after day, formed the spine of monastic existence. The individual hours might be brief, but together they shaped an entire mode of life, one not of haste or ambition, but of gentle recurrence. To live by the monastic hours was to live within a rhythm far removed from the outside world. Bells would ring out across the fields, calling monks from their labour or study. The sound of chanting would rise softly from within cloistered walls, not as performance, but as offering. Psalms were recited not once but many times, their verses becoming like breath woven into the very act of being. Over weeks and months, the entire Psalter, all 150 psalms, would be sung and re-sung, allowing the sacred words to take root in memory and in heart. Time within this framework became a kind of prayer. The days did not blur together, but took on texture, each hour inviting a different mood, a different kind of reflection. The early light of lauds might bring hope or stillness. Sext, under the weight of the midday sun, might prompt thoughts of weariness or patience. And Compline, in the hush of night, whispered of mortality, humility, and peace. Practical concerns, of course, still needed tending. Monks worked, tended gardens, copied manuscripts, administered estates. But these tasks were set within the wider frame of the hours. A bell might interrupt a task, but it was not an interruption. It was a return. To leave the field and walk slowly back to chapel was not to stop one's work, but to complete it. The instruments of time within monasteries were modest. In the early centuries, the ringing of bells might be governed by nothing more than observation, the movement of the sun, the length of shadows. Some communities employed water clocks or clepsydras to maintain more consistent intervals, particularly for the night offices when light was scarce. Later, candle clocks and eventually mechanical devices would be introduced, but in these early medieval centuries, time remained a matter of habit, tradition, and attentive presence. It is striking to consider how these communities, so apparently removed from the bustle of life, helped to preserve and shape the very notion of time across Europe. In an age when civil administration had collapsed in many regions, It was the monasteries that kept calendars, copied texts, observed feast days, and maintained a sense of continuity. They observed Easter with precision, marked solstices and saints' days, and passed on the rhythms of the year in chant and record alike. This quiet stewardship of time was not without its subtleties. The monastic day did not always begin at midnight or sunrise, but was often reckoned from matins, leading to variations in how hours were calculated. The length of daylight hours still shifted with the seasons, especially in northern Europe, where winter days were short and summer ones long. Monks adapted, adjusting their routines gently with the light, much as their ancestors had done with sundials and shadows. But what distinguished the monastic rhythm was its purpose. Time here was not measured for productivity or profit, but for presence. To pause 8 times a day, not for urgency but for prayer, is to adopt a different relationship with the passing hours. It is to treat time not as a series of tasks to complete, but as a series of gifts to receive. Imagine for a moment the daily life within a stone-walled abbey, perhaps nestled in the green hills of Northumbria or perched along the Loire. The bells sound at first light. A handful of figures stir from their beds, cloaked against the morning chill, and make their way in silence to the chapel. Their voices rise, not strong, but steady, joined in simple chant. Later, they tend to the beehives, or illuminate sacred texts, or prepare bread in the dim kitchen. Each task done slowly, with care, interrupted gently by the next hour's call. There is a timelessness in such a life, and yet also a deep awareness of time's movement, not the time of clocks and appointments, but the time of the body and the soul, of breath and hunger and praise. This is time not as pressure, but as pattern, and for those within it, the hours do not pass, they unfold. Through this rhythm, the monasteries created a sanctuary, not just of space, but of time. A world where each moment, however brief, was marked with intention. In doing so, they preserved a kind of time that might otherwise have been lost. A time shaped not by urgency, but by care. Not by conquest, but by reverence. As the Middle Ages progressed, a quiet transformation began to take place, not one heralded by fanfare or revolution, but by the gentle turning of wheels, the soft clink of weights, and the measured swing of rudimentary pendulums. From the contemplative rhythms of monastic hours, timekeeping began to enter a new realm, mechanical, intricate, and increasingly public. It was a change as subtle as it was profound, the moment when time itself began to tick. The roots of mechanical timekeeping stretch back to the closing centuries of the medieval world. It is difficult to pinpoint a single moment of invention. Rather, we find a slow evolution, born of necessity, curiosity, and quiet ingenuity. The water clocks of earlier centuries had offered a dependable method, but they were limited, sensitive to temperature, prone to irregular flow, and difficult to maintain with consistency across the changing seasons. Into this space stepped the mechanical clock. At first, it was not the instrument we might picture today. No hands upon a face, no minute divisions. These earliest clocks, emerging in Europe around the 13th century, were weight-driven devices built around a simple but revolutionary concept: the escapement mechanism. The escapement, though modest in appearance, was an ingenious solution. It regulated the release of energy from a descending weight, allowing it to drive a series of gears at a steady pace. Each motion was checked and released in turn, creating a sequence of controlled impulses. This was, in essence, the heartbeat of the mechanical clock, not fluid or variable like water, but deliberate and repeatable. It was the beginning of time made mechanical. The earliest known mechanical clocks were installed in monasteries and cathedrals, fitting, perhaps, given the long monastic tradition of dividing the day by the hour. These new devices served not only to toll the hours for prayer, but to keep them with greater consistency. A monk might still listen for the bell, but now the bell itself knew when to ring. One such early clock was built at the Cathedral of Salisbury in the late 14th century. It had no face, no hands, only a system of gears, pulleys, and a bell struck by an iron hammer. Yet it marked each hour with a quiet authority, echoing across the cloisters and fields, guiding the lives of both monks and townsfolk alike. As the technology spread, so too did its visibility. Tower clocks began to appear in town squares and civic buildings, their great dials facing outward, their bells tolling the passage of hours for all to hear. No longer hidden in monasteries or palaces, timekeeping had become a public act, an audible presence in the lives of farmers, merchants, and travellers. The city of Milan, in the year 1335, saw the installation of one of the earliest public clocks known to strike the hour. From then on, such mechanisms became symbols of civic pride and technological prowess. Towns competed not only in commerce or architecture, but in the precision and grandeur of their clocks. These early mechanical clocks were often large, intricate machines. Their cases were crafted in iron or wood, their gears turned slowly by suspended weights, their dials marked with Roman numerals or Gothic script. Some were adorned with figures that moved, a saint raising his hand, a king turning his head, or with celestial globes that tracked the phases of the moon or the movement of planets. In places like Prague, Strasbourg, and Wells, astronomical clocks began to appear, capable not just of measuring hours, but of representing the heavens themselves. These were as much marvels as instruments, part theology, part science, part art. They did not divide time solely for utility, they celebrated it. And yet, for all their grandeur, these early mechanical clocks remained imprecise by modern standards. Their accuracy depended on the steadiness of the escapement, the condition of the weights, the careful winding by hand. Even so, they represented a significant shift from natural rhythms to human-made ones, from observation to mechanism, from fluid time to segmented time. In this new world, time could be divided into equal parts, regardless of season or sunlight. An hour became an hour. Not longer in summer, nor shorter in winter. The fixed-length hour was born, and with it a different way of living. No longer tied to the light, to the sun's movement, to the rhythm of prayer alone, time began to stand apart, consistent and impartial. This quiet revolution unfolded over generations. The ticking of clocks, once unfamiliar, became commonplace. In towns and cities, people began to speak of appointments, not just by part of day, morning, dusk, supper, but by the hour itself. To meet at the 9th hour gave way to meeting at 3 o'clock. With this change came a shift in perception. Time was no longer something one simply lived within. It became something one could count, manage, even own. The medieval craftsman might measure his day not in prayers, but in tasks per hour. The merchant might pace his dealings to the chime of the clock tower, and the monk, still rising for matins, now heard a bell governed not by shadows or seasons, but by the gearing of brass and the tension of chords. Still, these early clocks retained something of the world they came from. Their mechanisms were hand-forged, their dials artistic, their purpose often as much spiritual as practical. They were not yet tools of haste or industry, but companions in the day's slow unfolding. To hear their bell was to be reminded of the passing hour, not with anxiety, but with a sense of order, of rhythm, of place. As the 15th century progressed, smaller domestic clocks began to appear, still rare, still costly, but now within the reach of the wealthy. These were weight-driven or spring-powered, set upon mantelpieces or mounted on walls. They brought the ticking of time indoors, into the private sphere, where it became something more personal. And so, through slow increments and turning gears, time entered a new phase, one not of stars or candles, but of wheels and weights. The world did not change overnight, but the quiet ticking spread, one clock tower at a time, one bell at a time, 1 hour at a time. In this unfolding, we see the blend of artistry and accuracy, devotion and invention. We see time becoming not only measured, but measurable, a soft echo of the heavens, now rendered in metal and motion. It was not the end of old rhythms, but the beginning of their transformation, the shaping of time into something both tangible and shared. As the mechanical clock matured, so too did its influence. No longer a curiosity of the monastery or the manor house, the clock became something encountered by all, tolling from the steeple, mounted on town walls, hanging above marketplaces and bustling intersections. With its growing presence, time itself began to assume a new and firmer place in the fabric of everyday life. It was no longer merely observed, it was followed. The emergence of public clocks in the late medieval and early modern periods marked a gentle but unmistakable shift in how communities related to time. Where once bells had rung loosely by custom or the priest's discretion, now they rang according to wheels and weights, unerring, impartial, and insistently regular. The sound of time was no longer confined to the cloister. It moved across cobbled streets, through shop fronts and workshops, over fields and alleys, marking not just hours of prayer, but hours of work, of rest, of meeting and parting. In towns throughout Europe, from Nuremberg to Norwich, clock towers became a common feature. They served not only a functional role, but a symbolic one, embodiments of civic pride, technological achievement, and collective rhythm. The town clock did not belong to one man, one guild, or one faith. It belonged to the people. Its tolling was heard by all, and in its sound, a shared sense of time slowly took root. One might picture in such a town the gentle unfolding of a market day. At dawn, the bell rings, a single resonant note spreading outward like ripples. Bakers open their shutters, the scent of bread mingling with mist. Traders begin to arrange their wares. At the 3rd hour, another chime. A messenger arrives, his journey timed to the hour's turning. By midday, the square is full, voices rise, transactions are made, and the world moves in concert with the slow cadence of the clock. This regularity brought with it both comfort and expectation. Artisans might begin their day at a specific toll and close their doors at another. Taverns might serve drinks at the hour agreed upon by town ordinance. Schools, increasingly common by the 16th century, structured lessons around set intervals. And in churches, though the divine office continued, it was now frequently aligned with the bell of the public clock. In cities such as Venice, Bruges, and Lübeck, where trade flourished, timekeeping also became a matter of economic significance. Merchants negotiated contracts with reference to specific hours. Ships were scheduled to depart by clock time, not merely by tide or sun. The regulation of work hours, particularly in crafts and guilds, began to take on new precision, laying quiet groundwork for the transformations that would follow in the industrial era. Yet for all its structure, time remained a communal affair, not yet fragmented by private clocks or personal watches. One knew the hour not by looking inward, but by listening. The bell tolled and life responded. Even those who could not read or reckon with numbers could follow the pattern of chimes. Time was shared, and in being shared it was softened, part of the gentle rhythm of the day, rather than a private metric of efficiency. Clocks themselves grew more elaborate. In Strasbourg, the astronomical clock was rebuilt with extraordinary complexity, displaying not only hours but celestial movements, liturgical cycles, and mechanical figures that moved in silent procession. In England, the Salisbury clock, already centuries old, continued to chime faithfully, even without a dial. These machines were marvels, but they also became familiar, almost familial, in their presence. The town knew its clock, and the clock, in a quiet way, knew the town. In smaller villages, the influence was slower but no less profound. A single bell, rung by hand, or guided by a small mechanism, could mark the shape of the day, the angelus in the morning, the midday prayer, the curfew bell in the evening. These sounds formed a kind of temporal landscape, as familiar as the hills or the river, not visual, but oral, textured by the pace of daily life. This period also saw the beginnings of time discipline, though in forms still gentle by modern standards. Monasteries had long regulated life with precision, but now secular institutions began to adopt similar habits. Town councils kept minutes of meetings, workshops recorded hours worked, and schools began to issue timetables. These developments were not universal or uniform, but they signalled a quiet shift in expectation that time might be accounted for. At the same time, the domestic clock began its slow emergence. Still expensive and rare, these household devices, often ornate and symbolic, found a place in the homes of the wealthy and the learned. Their presence brought the tick of time inward into the chamber and parlour, where it joined the fire's crackle and the rustle of pages. Even in such homes, however, time retained a measured grace. The ticking was not constant as it is today. Clocks were wound by hand, set by reference to the town bell, and sometimes allowed to rest. Time remained something observed, not enforced, a presence in the room, not a ruler of it. In paintings from this period, one might see clocks included not for their function, but as symbols, a reminder of mortality, of order, of the fleeting nature of life. The ticking of time, like the flickering of a candle or the fall of an apple, was part of the vanitas, the gentle admonition to live well, to reflect, to cherish the present moment. And so, as the mechanical clock became more widespread, it did not immediately bring with it anxiety or haste. Rather, it settled into the rhythm of the world, offering structure without sternness. The bells did not rush the baker nor scold the farmer. They marked the day, and the day unfolded in reply. In this way, time passed not only through gears and hands, but through lives, counted, yes, but not hurried. Time was a companion, not yet a master, and in its public tolling, a town found its rhythm, not as a matter of precision, but as a matter of belonging. As Europe expanded its horizons beyond familiar shores and ventured further into the vast, unknowable oceans, the question of time took on a new urgency. No longer merely a measure of daily life or religious devotion, time became a matter of navigation, of discovery, and at times of survival. At sea, where the sun and stars offered the only markers against a shifting and featureless horizon, the ability to keep time became not just a scientific challenge, but a pressing practical concern. The heart of this concern lay in one particularly stubborn problem: the determination of longitude. Latitude, the measure of north and south, had long been understood. It could be estimated with reasonable accuracy by observing the angle of the midday sun or the height of the pole star above the horizon. But longitude, the measure of east and west, proved more elusive. There were no fixed celestial points to serve as markers, no simple way to tell how far one had travelled around the Earth's circumference. To solve this, one needed to know the precise time at a fixed reference point, typically the home port or a known meridian, and compare it to the local time at sea, determined by the position of the sun. For each hour of difference between the two, a ship had travelled approximately 15 degrees of longitude. In theory, it was elegant. In practice, it was nearly impossible, because no clock at that time could keep accurate time aboard a ship. The difficulty lay in the nature of early clocks. Pendulum clocks, which had become increasingly reliable on land by the 17th century, failed at sea. The rolling motion of the ship disrupted the swing of the pendulum, while variations in temperature and humidity affected the tension of springs and the expansion of metals. A voyage might last weeks or months, and even a small drift in the clock's accuracy could lead to significant navigational errors, enough to miss an island entirely or run aground on an unseen reef. This problem was more than theoretical. Misjudged longitudes had real consequences: lost ships, delayed voyages, lives taken by starvation or storm. The tragic wreck of the British fleet under Admiral Sir Cloudesley Shovel in 1707, which resulted in the loss of over 1,400 sailors off the Isles of Scilly, was one such disaster, caused in part by a miscalculation of longitude. In response, the British government passed the Longitude Act in 1714, offering a prize of £20,000, a vast sum, to anyone who could devise a method of determining longitude at sea with sufficient accuracy. It was a challenge that drew astronomers, mathematicians, inventors, and charlatans alike. Among them was John Harrison, a self-taught carpenter and clockmaker from Yorkshire. Harrison believed that the key lay not in refining the pendulum, but in abandoning it entirely. He set about designing a new kind of timekeeper, one that would remain stable and accurate on the rolling deck of a ship, enduring heat, cold, damp, and salt air. His solution evolved through several prototypes, culminating in the creation of the H4, a compact marine chronometer resembling a large pocket watch, completed in the 1750s. It used a balance wheel rather than a pendulum, was made with temperature-compensated materials, and featured innovations in lubrication and friction reduction that allowed it to keep time with extraordinary accuracy. To test the device, the H4 was sent on a sea trial to Jamaica aboard HMS Deptford in 1761. It performed with remarkable success, losing only 5 seconds over a voyage of several weeks, a level of precision that allowed the ship's longitude to be calculated within a few nautical miles. Yet, despite the clear success, official recognition was slow. Harrison would spend many years petitioning for the full prize, which was gradually paid in portions only after considerable dispute. Still, the implications were far-reaching. With the advent of the marine chronometer, seafaring changed. Captains could now fix their position with far greater confidence, chart new routes, and return with more certainty. The great voyages of exploration, colonization, and trade that mark the late 18th and 19th centuries were underpinned by this quiet achievement, the taming of time at sea. Chronometers became standard equipment aboard naval and merchant ships alike. Kept in padded boxes and handled with care, they were treated with reverence. Often, 2 or even 3 chronometers would be carried, checked against one another, and corrected by observation of celestial events. Their time was sacred, their presence essential. But the impact of maritime timekeeping was not confined to ships. It rippled outward, shaping map-making, trade schedules, and the very understanding of the globe. As travel times became more predictable, commercial routes expanded. Port cities grew in complexity, coordinating arrivals and departures to the hour, and as more accurate maps were drawn, with longitudes properly measured, the world itself seemed to grow smaller, more knowable, more precise. At the same time, this mastery of time and position deepened humanity's relationship with the heavens. Astronomy and navigation remained intertwined, and many observatories, like the Royal Observatory in Greenwich, served both as centres of scientific research and as timekeepers for the empire. The prime meridian, established at Greenwich in 1884, would become the standard reference point for measuring longitude, and eventually for setting global time zones. Thus, the problem of longitude, once a sailor's nightmare, became a gateway to a new age of coordination, exploration, and global connection. It began with a question of hours, but ended by redrawing the map of the world. And through it all, time remained a quiet presence. No longer just a tolling bell in a village square, but a precise measurement tucked into the brass casing of a chronometer, ticking gently as waves rolled beneath. It was a time not for prayer or harvest, but for position and passage, a time to steer by, to measure one's distance from home, and to find a path through the great openness of the sea. As the world moved into the late 18th and early 19th centuries, time, which had once told gently from church towers and glinted from the hands of elegant pocket watches, began to assume a firmer, more insistent role in the rhythm of daily life. The Industrial Revolution, with its steam-powered machines and expanding cities, brought about not only new ways of working, but new ways of thinking about time itself. No longer a backdrop to life's quiet unfolding, time became something to be spent, managed, measured, and often controlled. In the pre-industrial world, most people lived according to the soft, irregular rhythms of natural time. Farmers rose with the light, tended their fields according to the seasons, and paused their work when darkness fell or weather intervened. Artisans worked at their benches as needed, pausing for meals or conversation without glancing at the clock. Even in towns, where public clocks rang out from towers, the pace of life remained relatively fluid, guided more by task than by the strict turning of the hour. But the factory changed all that. With the emergence of mechanized production in Britain's growing industrial towns, Manchester, Birmingham, Leeds, came a new emphasis on punctuality and duration. Machines could not wait for daylight or human mood. They ran when started, halted only when stopped, and demanded a regularity that transformed the human experience of time. Workers were expected to arrive at set hours, to remain for specified shifts, and to align their movements with those of the machines they operated. This new discipline was not imposed gently. In many early factories, gates were locked at the beginning of a shift, and anyone arriving even a few minutes late might lose a full day's wages. Clocks were installed in prominent positions, and their ticking became a kind of overseer, marking the boundaries of work and rest with a newfound rigidity. Time, once observed in the movement of the sun or the ringing of the church bell, was now marked by whistles, horns, and the shrill buzz of factory bells. It became an employer's commodity, a measure of output, a line in a ledger, something that could be stolen or wasted if not used efficiently. To be on time became not merely a virtue, but a necessity. This shift had profound effects on the fabric of society. For workers, especially those migrating from rural areas to industrial cities, the adjustment was significant. Life, once governed by light and weather, was now ruled by clocks. The concept of wage labour, being paid for one's time rather than one's output, became widespread. Each hour had a price, and each minute could be counted. In this new world, time was divided and subdivided. The 8-hour shift emerged not immediately, but gradually, often after long struggles and negotiation. Before this, workers might endure 12, 14, even 16-hour days. Children, too, were caught in this regime, rising before dawn, toiling through the day, their growth and education often stunted by the unyielding grip of the factory bell. The working week, too, became more clearly defined. Sunday remained a day of rest in most places, but the remaining 6 were carved up with increasing precision. Even leisure began to be measured: the hour for tea, the evening promenade, the half-day holiday. Trains, postal services, and eventually schools all followed suit, aligning themselves to this new, more exacting temporal order. Within this world, the clock became an omnipresent symbol. Factory walls bore them, train stations centered around them. Homes increasingly began to include modest timepieces, whether pendulum clocks in the parlour or pocket watches on chains. Even those who could not afford a watch might glance at the town hall tower or listen for the regular whistles of the local mill. The phrase "time is money," popularized by Benjamin Franklin, encapsulated this new understanding. It was not just a figure of speech, but a cultural shift, one that gradually took root not only in industry, but in the broader habits of life. Efficiency became a virtue. Idleness, once a space for reflection or community, began to be viewed with suspicion. The unmeasured hour, the unscheduled afternoon, the long and aimless walk, these began to seem less innocent, more wasteful. Yet not everyone welcomed this transformation. Poets and philosophers of the era frequently expressed discomfort with what they saw as the mechanical encroachment on human spirit. William Blake, with his vision of dark satanic mills, spoke not only of pollution and labour, but of the loss of older, gentler rhythms. John Ruskin and William Morris, champions of the arts and crafts movement, decried the regimentation of work and the dehumanizing effects of the clock. They longed for a return to craftsmanship, to time shaped by care rather than speed. In some quarters, efforts were made to soften the edges. The concept of standard time, which would become increasingly important with the expansion of railways, was introduced to ensure that clocks in different cities agreed with one another, reducing confusion and missed connections. But even this brought a kind of abstraction. Time no longer tied to local noon or the sun's position, but to a national or even global average. Yet amid all this structuring, time remained something experienced, not merely counted. The factory worker might glance at the clock, but also feel the drag of the long afternoon, the quickening of footsteps at day's end. The mother at home might boil the kettle not by the minute, but by ear and intuition. The child might still measure the day by the length of the shadow on the playground wall. The Industrial Revolution thus brought a profound reorganization of time, one that rippled through work, rest, and thought. It was a change not of tools alone, but of values. Time became scarce, precious, valuable, and in becoming so, it also became, for many, a source of pressure. Still, even as the factory bell rang and the whistle blew, older rhythms lingered. In the countryside, the seasons still governed planting and harvest. In churches, the liturgical calendar continued to unfold. And in the quiet moments between shifts, in the hush of evening or the slowness of Sunday, people still found time to sit, to think, to be, reminding themselves, perhaps unconsciously, that while time might be measured, it need not always be rushed. With the arrival of the railway in the 19th century, time already reshaped by the ticking of factory clocks, underwent another transformation. No longer merely an element of personal routine or industrial discipline, time became a matter of public coordination, stretching across landscapes, threading through towns and fields, and requiring an unprecedented level of uniformity. In short, the railways introduced not just speed and mobility, but standard time, the quiet yet far-reaching foundation of the modern world. Before the railway, time remained, in many ways, local. Each town and village set its clocks according to the position of the sun, usually high noon, when the sun stood at its zenith. This meant that time varied slightly from place to place, often by just a few minutes, but enough to be noticeable over distance. A traveller might leave Bristol at what the local clock deemed noon, only to arrive in London an hour later to find the clocks slightly ahead. This variation, while manageable in a world of horses and walking, became problematic with the coming of the train. Trains, unlike carriages, moved with unrelenting regularity. They adhered to timetables, departed and arrived according to published schedules, and required every station along the line to operate in synchrony. But if every town used its own local time, coordinating these journeys became a challenge. Even a small difference of 5 or 10 minutes could lead to confusion, a missed train, a delay, or worse, a collision on a single-track line where precise timing was essential for safety. The answer was railway time, a single standardized time adopted across the network, typically based on the time at a central observatory. In Britain, this was Greenwich Mean Time, established at the Royal Observatory and already used by astronomers and navigators. Beginning in the 1840s, railway companies began adopting Greenwich time for their timetables, even if local clocks remained unchanged. At first, the transition was quiet, informal. Station clocks were adjusted. Train guards carried timepieces set to Greenwich. Timetables bore small notes indicating that times listed followed London time. But as the railway spread, with new lines reaching deeper into rural areas, the pressure to adopt a single standard time increased. By 1855, most public clocks at railway stations across Britain had aligned with Greenwich Mean Time, even if town hall clocks lagged behind. The standard became official in 1880 when Parliament passed the Statutes Definition of Time Act, formalising Greenwich Mean Time as the legal standard across the country. Similar developments took place elsewhere. In the United States, with its vast and expanding rail network, the need for coordination became critical. In 1883, American railroads collectively adopted a system of 4 standard time zones, dividing the continent into manageable segments and reducing the confusion of local time variations. This decision, made not by government but by industry, brought coherence to the schedule and laid the groundwork for federal standardization, which followed in 1918. Standard time, once introduced, brought more than just order to the railways. It subtly transformed everyday life. Clocks in schools, offices, post offices, and homes were adjusted to match the new norm. People began to organize their days not by the sun's position, but by the precise tick of the station clock. The idea of a correct time, measurable, consistent, and uniform, took hold. In this new world, the public clock became a kind of compass. Towns synchronized themselves to railway time, and railway time synchronized itself to Greenwich. The bell that rang from the steeple or the signal that flashed at the signal box no longer echoed a local rhythm but a national one. Even those far from any railway felt its presence in the regulated structure of their day. Yet this standardization was not without its quiet resistances. Some towns clung to their local time for a while, maintaining 2 clocks, one showing local solar time, the other Greenwich. The older generation sometimes referred to sun time or true noon, and a few communities treated railway time as a kind of imposition, useful but external. Over time, though, these distinctions faded, and standard time became second nature. What is striking about this transition is how gently it occurred. Unlike revolutions or decrees, the shift to standard time unfolded through practice. It was not enforced with severity, but adopted because it worked, because it brought clarity to a world that was, quite suddenly, moving faster and further than ever before. Railway time was not just a matter of trains. It became the architecture for timetables, appointments, school bells, postal deliveries, and business hours. It enabled synchronized action across wide distances. A meeting arranged in London could be planned to coincide precisely with one in York or Edinburgh. News travelled with new reliability. The telegraph, working hand in hand with the railway, transmitted information across regions bound by the same temporal grid. This coordination had its quieter echoes as well. Factory whistles, long governed by their own internal clocks, began to align with railway time. Church bells, once rung at local noon, now chimed according to standard hours. Even domestic life began to shift. Meals scheduled with a new regularity, excursions planned around the departure of a train. In cities, the rhythm of life became increasingly punctual. Offices opened and closed with greater precision. Public lectures, concerts, and performances adhered to printed times. Shops advertised their hours clearly. Punctuality, once a matter of manners, became a matter of necessity. And through it all, the clock stood quietly as a symbol, not merely of time, but of order, coordination, and progress. It was mounted above platforms, painted on station walls, embedded in pocket watches and wall clocks. The ticking of the train and the ticking of the clock became intertwined, a soundscape of the modern age. Yet for all this precision, time retained its human texture. People still watched the weather, still marked the seasons, still experienced days as long or short, dull or vivid. The clock might mark the hour, but the moment still belonged to the person living it. The introduction of railway time reminds us that time, while abstract, is also profoundly practical. It shapes not just thought, but movement. It connects distant places, makes plans possible, and lends shape to our days. And in the quiet hum of a station, in the rustle of a timetable, in the click of a clock at the end of a platform, we can still hear the echo of that great synchronizing, the moment when the world agreed, more or less, on what time it was. As the 20th century unfolded and technology advanced at an ever-quickening pace, the question of time, its measurement, its precision, its very nature, assumed a new dimension. Having tamed it with sundials, regulated it with gears, and synchronized it with trains, humanity turned its gaze inward toward the deepest structures of matter itself. Time, once marked by shadows and chimes, was now to be counted in vibrations, not of bells, but of atoms. This chapter in the long history of timekeeping begins not with bells or clock towers, but in laboratories, quiet, clinical, full of hums and blinking lights. It was here, in the mid-20th century, that physicists sought a new kind of timekeeper, one that would be free from the limitations of pendulums and springs, resistant to temperature and pressure, and capable of a consistency so fine that its drift might be measured in millionths of a second per year. The atomic clock was not conceived to replace the time of daily life, the hours of trains and shops, meals and meetings, but to provide a new foundation beneath it, a time so stable, so precise, that all other clocks could be set against it. It was, in a sense, the distillation of time into its purest form, not lived time, not experiential time, but time as frequency. The principle behind the atomic clock is, in essence, quite elegant. Certain atoms, when energized, resonate at highly consistent frequencies. The most famous of these is the cesium-133 atom, which, when stimulated, oscillates 9,192,631,770 times per second. It is this vibration, steady, unchanging, and universal, that forms the basis of the atomic second. In 1967, the General Conference on Weights and Measures adopted this definition officially. 1 second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium-133 atom. With this, the second was no longer tied to the Earth's rotation or to the movements of celestial bodies. It became, for the first time, wholly abstract, rooted in the immutable dance of the atomic world. The development of the first operational atomic clock took place at the National Physical Laboratory in the United Kingdom in 1955. Its accuracy exceeded anything previously achieved. Other laboratories soon followed, in the United States, France, Japan, building clocks that agreed within billionths of a second. These devices were large, complex, and fragile, but they marked a turning point. Time could now be measured not only with extraordinary precision, but with global agreement. This new accuracy had wide-reaching effects, some obvious, others more subtle. Navigation systems, such as GPS, rely on atomic clocks to function. Satellites circling the Earth broadcast time signals derived from these clocks, and receivers on the ground calculate position by comparing the delay between signals. A discrepancy of even a microsecond would result in a navigational error of hundreds of meters. Thus, atomic time allows planes to land, ships to steer, and mobile phones to triangulate their location. Communications networks, too, depend on precise timing. Digital signals, synchronized across vast infrastructures, rely on atomic clocks to prevent data collisions and ensure coherence. Stock markets, scientific experiments, power grids, all function more smoothly, more safely, thanks to this hidden heartbeat of cesium and rubidium. Beyond the practical, atomic time also allowed for deeper study of time's behavior itself. Einstein's theory of relativity predicted that time is not constant, that it flows differently depending on speed and gravity. Atomic clocks confirmed this with striking clarity. Clocks placed at different altitudes or aboard fast-moving aircraft began to diverge in measurable ways, proving that time itself is, in some sense, local, affected by position and movement. This leads us gently into a new understanding of time, not simply as something to be measured, but something that behaves, something elastic, responsive, woven into the very fabric of space. Time is not, as Newton once imagined, an absolute container within which events unfold. It is rather part of the event itself. And yet, for all this complexity, atomic time retains a kind of quiet. These clocks do not tick or tock. They emit no chimes, mark no hours. They sit in sealed rooms, carefully temperature-controlled, shielded from electromagnetic noise, their workings unseen by the public. But their influence stretches outward through cables, signals, protocols, shaping our world with a precision most will never notice. International time is now coordinated through a system called Coordinated Universal Time, or UTC. It blends atomic time, known as International Atomic Time, or TAI, with periodic adjustments called leap seconds, which account for slight irregularities in the Earth's rotation. These adjustments ensure that our civil time remains loosely tethered to solar time, though the bond grows ever more tenuous. Some have questioned the need for these leap seconds, suggesting that they introduce complications in digital systems that prefer continuity to accuracy. Others argue that without them, midnight might eventually drift into morning and the sun no longer rise at 6. It is a debate not about measurement, but about meaning, about how closely our clocks should reflect the natural world. What is perhaps most striking in this age of atomic precision is the widening gap between measured time and lived time. One can now measure a second to the width of a strand of light, but this tells us little of how it feels to wait for a kettle to boil, or how a sleepless night unfolds minute by minute. The atomic clock has given us mastery over time's quantity, but not its quality. Still, there is something quietly moving about this pursuit. To spend years refining an oscillator, cooling atoms to near absolute zero, isolating vibrations with such care, all to measure something we can never hold. It speaks to a kind of reverence, a belief that in knowing time more exactly, we might know something more of ourselves. And so in laboratories around the world, the seconds continue to count themselves out, not in ticks but in frequencies, invisible, inaudible, yet ever present. They remind us that even in an age of incredible speed, there is still room for stillness, for the slow, patient shaping of knowledge, for the quiet unfolding of understanding. While engineers and scientists pursued the precise measurement of time through gears and atoms, philosophers continued to ask quieter, deeper questions. Questions not about the accuracy of a second, but about what a second means. Time, for the thinker, is not merely something to measure. It is something to experience, to reflect upon, and, at times, to doubt. In the early 20th century, at the very moment when atomic clocks were just beginning to hum and vibrate, two very different minds came into conversation and conflict over the nature of time. One was Albert Einstein, physicist, mathematician, the architect of relativity. The other was Henry Bergson, French philosopher, poet of the inner moment. Their disagreement, played out in lectures and letters, came to symbolize the divide between objective and subjective time, between the measured and the felt. Einstein, through his theories of special and general relativity, revealed that time is not fixed. It bends with gravity, stretches with velocity. A clock on a speeding train ticks differently from one at rest. A second near a black hole lasts longer than one on Earth. These were not metaphors or philosophical positions. They were measurable, demonstrable truths. Time, in Einstein's universe, is woven into space, forming a single four-dimensional fabric known as space-time. It is physical, malleable, and in some ways indifferent. Bergson, however, was concerned with time as it is lived. He distinguished between two kinds of time: temps, the time of science and measurement, and durée, or duration, the time of consciousness. Duration, for Bergson, was fluid, continuous, immeasurable. It is the time we feel when we lose ourselves in thought, when a moment stretches or contracts, when memory folds the past into the present. He argued that time could not be reduced to numbers and intervals without losing something essential. Real time, lived time, was not a series of discrete points, but an unfolding flow, like a melody whose meaning depends not on individual notes, but on their relation and rhythm. To measure time, he claimed, is already to abstract from it. We pin it down, but in doing so, we flatten its depth. Their famous meeting in 1922 at the Société Française de Philosophie in Paris ended in polite disagreement. Einstein held that time is what clocks measure. Bergson insisted that time is what we feel. And while the scientific community largely sided with Einstein, the conversation never truly ended. It continues in subtler ways, in the quiet thoughts of anyone who has ever felt time pass too quickly, or not quickly enough. Beyond these two figures, the 20th and 21st centuries have seen a wide array of philosophical reflections on time. Martin Heidegger, in Being and Time, placed temporality at the heart of human existence. For Heidegger, to be is to be in time. We are always moving toward the future, shaped by our past, engaged in the unfolding of the present. Time, in his thought, is not something we have, but something we are. Similarly, the French philosopher Paul Ricoeur explored time in relation to narrative. In his 3-volume work, Time and Narrative, he examined how stories help us make sense of time, how we organize past, present, and future into a meaningful arc. Our memories, hopes, and regrets are not filed chronologically, but woven into stories that give shape to our lives. Time, for Ricoeur, is not just a sequence of events, but a structure of understanding. In more recent thought, philosophers have questioned whether time exists at all in any ultimate sense. Some interpretations of quantum physics suggest that time may be emergent, not fundamental, but arising from deeper, timeless structures. Others explore the possibility that all moments, past, present, and future, coexist in a block universe, where time is an illusion of perception and every event simply is, eternally. Such views are deeply abstract, but they echo an old philosophical instinct, the sense that time, for all its apparent familiarity, resists our full understanding. It is at once intimate and remote, measurable and mysterious. We can record it with perfect precision, and yet still wonder where it goes. For the person lying awake in the middle of the night, or walking slowly beneath autumn trees, time is rarely experienced as a clean sequence of seconds. It slows, stretches, returns upon itself. A scent or a sound may bring the past vividly into the present. An anticipated moment may seem endlessly delayed. A joyful hour may vanish, while a dull one drags. These are not anomalies. They are the texture of time as lived. Philosophers, poets, and even scientists have long recognized this dual nature of time. T.S. Eliot, in 4 quartets, wrote of time past and time future. What might have been and what has been point to one end which is always present. Augustine of Hippo, writing more than 1,000 years earlier, asked, "What, then, is time? If no one asks me, I know. If I want to explain it, I do not know." In such reflections, time becomes more than a background condition. It becomes a mystery, a question, a companion. It shapes not only our days, but our sense of self, our memory, our identity, our hope. To reflect on time is, in some ways, to reflect on life itself. And yet, for all its complexity, time remains deeply ordinary. It is in the way bread rises, the way leaves fall, the way shadows lengthen on a wall. It is the rhythm of footsteps, the hush before dawn, the moment of stillness before sleep. It is not always a problem to solve or a quantity to manage. Sometimes it is simply something to sit with, to notice, to feel, to let be. In this way, the philosophical journey through time brings us not to certainty, but to a kind of peace, a recognition that time is not only what we measure, but what we live, that it is both the ticking of the clock and the silence between ticks, both the unfolding of galaxies and the hush of thought. It is, as Bergson knew, not a line, but a flow, and we are in it, always. As the 21st century unfolds, time finds itself immersed in yet another transformation. Quieter perhaps, but no less profound. It is a time not marked by the slow swing of a pendulum or the steady tick of a wristwatch, but by the silent flicker of pixels and the whispering pulse of invisible signals. Digital time is everywhere, precise, omnipresent, and, paradoxically, almost imperceptible. We no longer need to wind clocks or consult public towers to know the hour. It glows gently from our pockets, our screens, the corners of our appliances. Phones adjust themselves in the night, syncing with global servers. Computers display time not only to the second, but sometimes even to the millisecond. Though few of us ever look so closely, the time is always right, and yet rarely noticed. This new environment of time, fluid, automatic, exact, creates a curious sensation. We are surrounded by time more than ever, and yet we feel it less. The analog rituals of setting a watch, of waiting for the chime of the hour, of noticing the lengthening of shadows, these have faded into the background. In their place is a quiet, ambient awareness, always there, always updating, rarely questioned. Digital time flattens the experience of temporality. In a world where messages are instant, maps adjust in real time, and music streams without delay, the delays and textures that once gave time its feel have softened. Waiting, once a space for thought or observation, has been compressed. Many of life's intervals, the walk to the library, the queue at the post office, the afternoon without news, have been replaced by swipes, taps, and refreshes. And yet, in this abundance, something of time's weight seems to have diminished. Digital interfaces often obscure the passing of time, reducing it to a status bar or a spinning wheel. Days slip by in tabs and feeds, and one moment becomes indistinguishable from the next. We scroll not forward, but downward, into timelines that promise continuity, but rarely offer closure. In this way, time begins to feel both constant and directionless. The modern calendar, once a thick tome on the wall or a leather-bound diary, has become a silent, syncing service. It pings us with reminders, not bells. It repeats tasks and events endlessly, populating our weeks with obligation and routine. Time is no longer only a shared public rhythm. It is also a private architecture of appointments, alarms and prompts, tailored to each individual, yet strangely uniform. This hyper-personalization gives the illusion of mastery. We schedule, optimize, track. We wear watches that measure not just time, but steps, heartbeats, sleep cycles. We monitor productivity in blocks and charts, turning each hour into data. Time becomes something to manage, to improve, even somehow to perfect. But such control is partial at best. While our tools are precise, our experience remains human, subject to emotion, attention, memory. An hour in silence may feel long, a day on screens remarkably brief. Digital time may be standardized, but it has not removed our subjectivity. If anything, it has intensified the contrast between clock time and felt time. Moreover, digital culture has given rise to a curious sense of timelessness. Online, much of what we encounter is detached from its moment of origin. Articles, videos, messages, they appear without context, without season. A post written a year ago may resurface as if new. An old memory is served up by an algorithm, stripped of its former setting. We experience time not as a flowing river, but as a loop, fragmented, reshuffled, oddly suspended. The effect can be disorienting. Without clear beginnings or ends, without pauses marked by nightfall or communal rest, time online becomes a blur. The always-on nature of digital life, its alerts, updates, and endless novelty, flattens the week into a perpetual present. For some, this brings anxiety. For others, detachment. For all, it alters how time is perceived. At the same time, digital tools offer new ways to reconnect with time. Photographs are time's emissaries, freezing moments for later reflection. Digital journals, fitness logs, even email threads allow us to trace the path we've taken. These records offer a kind of archaeology of the recent past, not deep history, but micro-histories of our days. In them, we glimpse the texture of time regained. During global events, a crisis, a pandemic, a shared celebration, digital platforms can also reintroduce a kind of collective temporality. People post at once, gather in real time, mark anniversaries together. The clock becomes communal again, if briefly. The shared countdown to midnight on New Year's Eve, streamed across continents, retains a kind of magic. But even here, there is quiet tension. The more connected we become, the more fragmented our sense of time can feel. Notifications interrupt, tabs multiply, and the mind flits between moments without rest. In such an environment, it becomes harder to dwell, to rest in the present, to notice its shape. Some respond by seeking stillness. The growing interest in mindfulness, in slow living, in digital detoxes and analog routines reflects a yearning to step outside the rush, to reintroduce pauses, to live again by the rhythms of breath, of weather, of conversation. It is a gentle resistance, not to time itself, but to the pace imposed upon it. In this final turning of our journey, we find that time remains, as ever, both given and made. We inherit it as a constant, measured now with atomic precision, coordinated across satellites and screens. Yet we live it in ways that are tender, imperfect, and richly varied. The digital world offers speed, access, and scale, but it also invites reflection, a chance to ask not just what time it is, but how we are spending it. Not just how efficiently we move through tasks, but how deeply we dwell in moments. And so we return, quietly, to where we began. Time, whether counted in shadows, in grains of sand, in pendulum swings or atomic pulses, remains one of the great companions of human life. It passes through us and around us. It holds our stories, our days, our hopes. In this age of digital moments where time is everywhere and nowhere, perhaps the greatest gift is to remember that each moment, however brief, however ordinary, is still a place we can inhabit, not just measure, but live.